Okay, our next speaker has been leading the Hacker Garden during Jfokus, and now he's here to tell us about some libraries, perhaps even something that's being created right here?
Yes.
I don't know. Anyway, please welcome Andres Almiray.
Thank you, Peter. Hello, everyone. I'm very happy to be here at the main stage at Jfokus. This is my third time on this beautiful country and this excellent conference. And so as Peter has said, the topic of today is Java. You can't afford to miss. And you probably read the information on the abstract, but I'm going to get directly into the topic right ahead. So I have a challenge for you. I know that most of us have eventually have to deal with REST APIs in one way or another. Either we create the REST APIs or we consume the REST APIs. Now, the challenge for today is creating a client that is capable of consuming a REST API, and we're going to create it using Java. Well, because this is a Java conference. Now, there are many ways to do this. And the idea is to showcase a library or a set of libraries that will make this task much, much easier. But it's not just the fact that we need to consume a REST API. We also have to have components that are small, reusable, so that we can reuse it in other projects. We don't want to write boilerplate code. We might rely on IDE support or something extra. And of course, everything that we write has to be testable up to some point, right? Okay, so now that you have that in mind, these are the libraries that we're going to cover. And you probably have seen some of these already. Again, the point is you can't afford to miss these libraries. Some of these are very well known, and some others not so much, okay? So let's now get started with our disclaimer. All the libraries that we're going to see today are open source. I have nothing against commercial libraries or commercial offerings. It's just that, personally, I think it's easier to share information if it's open source. Now, if you find a problem using any of these libraries, I will highly encourage you to at least report the problem. And if you can fix the problem, much better. Excellent. My goal is for you to feel something like this at the end of the session. Let's see if I can accomplish this for a few of you. All right? Okay, so my name is Andres Almiray. I come from Mexico. I work for this company called Canoo. It's a company in Switzerland. We're a Java shop. We do Java. We do a lot of stuff with Java. We also love Groovy. I'm a member of the Groovy development team, so I love to mix and match Groovy and Java code. As Peter said, I'm also the lead of the Hacker Garden. You heard about the Hacker Garden yesterday at the keynote. We have had a couple of contributions, especially one of the libraries we're going to see today, and the Groovy language as well. Excellent. So again, to remind you what we're going to do today, we're going to build, or at least see how we can build a REST client with Java in order to consume a REST API. The API that I decided to base this application upon is the GitHub API. Why? Because it's very well known, it's very well documented. Most people have encountered GitHub in one way or another. So that link over there is the description of the latest version of the GitHub API. It's version number 3. It's a big document. You can learn many things about how you can chunk out your own REST APIs if you want to. Now, because it's so big, we're going to be interested in just a fraction of the operations. Specifically, we're only going to query repositories. So if you want to know the repositories belonging to a particular owner, whether it's a user or organization, that's the URL. You need to figure out how, read the documentation so you can see what elements can be sent into the GET or the POST query, and then what elements you get out as a result. It may be, most likely, it's going to be a JSON result. Okay? So basically, you issue a GET query, passing that organization as a name, as a parameter, depending on the library that you're going to use. And boom, as a result, you get a huge JSON payload with lots of information. We are only interested in a few of them for this particular small example, but you may be able to be interested in other things. Okay, so what we're going to need. In this time and age, I will say it will be very, very hard for people to come up with a new project or a new application without using some sort of dependency injection. So we need something to sort that out. We also need to, of course, use an HTTP client in some way. We need to adapt to the REST interface. We need to map JSON input and JSON output into Java objects because we're dealing with Java. We also would like to reduce the amount of code that we have to write because some of these libraries follow the approach of using plain Java objects. So we need getters and setters and following other conventions that just bloat our code. We just want to get rid of that. And of course, we will have to handle concurrency in some way. The example I'm going to show, actually, I guess it will be a good idea to show the example right away. I decided to build the application as a JavaFX application. Why? Because I love JavaFX. I'm a desktop guy. But you could use all these libraries you're going to see today. You can use it on the server side. You can use it on the cloud. It doesn't matter. It all just works. So the application that I have, and by the way, everything is running with Gradle, you will have access to the source code. As a matter of fact, here it is. Let's see if I can make it a little bit bigger. There we go. Perfect. So if I type the name of an organization here, I will be able to query all the repositories for that one. For example, let's say the Griffon repository, which is one of my passions, the Griffon framework. And there you go. It starts to boom, boom, network. Oh, I don't have any network. Nice. See, there is a problem. You should test network before you get into a demo. But I will be able to test this thing without a demo, without a network. Supposedly, I should have seen the list of all the repositories. Let's see if I can quickly fix that. And do we have network? Let's jump into the Jfokus network instead of the waterfront. That's probably the reason. Should have checked this earlier. And while this thing is going, let's jump back here. Perfect. OK, so the source code for today, you have access to this. All the source code is available in these repositories. There are several versions of these applications. I'm going to mix and match different libraries that can that can give you almost the same behavior depending on what you want to do. It's all open source. It's GPL. Just read, study, grow. If you find a bug, please let me know, and even better, contribute back. So the first thing we're going to cover is dependency injection. And I should say that if you had a question, please let me know. I will try to answer it as soon as possible. If not, we will also have time at the end of the session for some Q&A. So in the terms of dependency injection, I guess most of you know the next one, which is the idea is we have a component that defines a contract. In this case, it's an interface that defines a method called repositories, takes an argument, and returns some type of object, which we will see later. We want to use this component in some other component. So usually we do a new instance of that thing and then just use it directly. But if we use dependency injection, then things start to look like this way. We use an annotation like add-inject from JSR 330, the standard for defining how we use dependencies in Java. And that's pretty much it. Well, now we have to figure out how to bootstrap the dependency injector container. The one that I'm going to showcase today is Google Juice. Why? Because this is the reference implementation of JSR 330. Now, it's very easy to get started with Juice. All the definitions of the types that you want to inject into the container are done in Java code, so it's a programmatic API. You have different types of bindings. You can define bindings at the singleton level, that is a scope singleton, or you can define as a prototype, or you can define different scopes. You can add annotations for qualifiers. You can have even lazy instances being created through a notion called providers. Now, if you don't know Juice, but if you do know Spring, then providers are pretty much factory beans. It's pretty much the same thing. All right, so what I'm showing in this case is 3 different kind of bindings, but Juice actually supports 5 kind of bindings. You can also bind a constant value to a particular type. For example, bind the URL of the GitHub API to a string. I didn't show it here in the slides, but it is used in the code. If you look into the repository, that's how I can trick in production code what is the real URL, and if I do in test, I can point it to a different URL, which is controlled by the tests themselves. All right? So the reasons to use Juice pretty much is the reference implementation. You have all kinds of bindings. It's programmatic API. It's very easy to get started. It's very extensible. It has some caveats, for example. If you want some component to react once it has been created, once it has been instantiated, for example, we know in Java EE or in Spring, you can annotate methods with post-construct, right? Or if you want to react when the instance is going to be destroyed by the container, we can annotate a method with pre-destroy. Juice doesn't support this out of the box, but there are extensions that will allow you to gain back that behavior. One of those extensions is also used in the repository. So if you use Juice, then you get as a bonus another dependency. It's called Google Guava. You might have heard this already. Google Guava was created many years ago as a reaction of things that were missing in the standard Java library. Googlers said that they wanted to add also new collections. If you ever had the need to find what key is associated per a value, we know that in a map, you given a key, you get a value. But if given a value, you want to know which key is associated with that one, then what you need is a bimap. If you want to have a map that can contain multiple values associated with a key, we know that manually we can create the list and do the management. Is the list empty? Then we remove the key. If it's not there, then we create the list, yada, yada, yada. Well, the multi-map does this automatically for us. We just need to get put, and that's it. So we get new collections. We also get new constructs that allow you to have functional programming. This is before Java 8. Because in Java 8, we got Lambda expressions, and the consumer, supplier, optionals, and whatnot. So if you're still running in JDK 7 or earlier, then Google Guava will be a good thing to have in your project. You also have additional settings for handling I/O, reflection, caches, and a few things that are related to testing. So overall, it's a good library. And if I'm not mistaken, the next major release of Google Guava will require you to use JDK 8, Java 8 as a minimum. If you have not switched to Java 8 already, please do so quickly because Java 9 is supposed to come out this year. You don't want to be left out behind. Next one. If you're not using Juice, probably you're using Spring. There are many, many projects related to the Spring portfolio. And here I am only taking care of the original one, the Spring Framework. Spring Framework is, I guess, as close to between 2 megabytes and 3 megabytes of size. It contains a lot, not just the dependency container. Some people don't like Spring because you have to use configuration with XML, but for many years now, you can do configuration with just Java and annotations. So no more pain with XML. It supports also JSR 330, so the same annotations that you use in Juice, you can use in Spring. Has assertions, supports internationalization through message source. You can create JMX clients with the Spring Framework very, very easily. If you ever had the need to monitor an application through JMX, have a look at the JMX support from Spring. Testing support, very good. Validation, scaling, so many things that you get just with core Spring Framework. You don't need to turn into other libraries. OK, so that gets rid of the dependency injection. Let's see how we can reduce the boilerplate code. So we said we're going to deal with POJOs. So you probably know by heart the conventions for dealing with POJOs. We have to use the Java Beans convention, which means for every property, we need a getter and a setter. And if it's an indexed property, then you have different pair of methods. And if it's a well-behaved POJO, you have to implement the equals and hashcode method following certain algorithms, correct? These can get out of hand pretty quickly, even though I know that your IDE of choice can generate the methods using a template. Once the source code has been generated by the IDE, you are now in charge of maintaining that source code. Adding a new property is easy. Renaming a property is still easy. Deleting properties starts to get hard. And the moment that you start adding and moving things around, again, you are now maintaining machine-created code. Wouldn't it be better if we let those concerns still be handled by the machine, in a sense, be handled by the compiler, perhaps? And that's exactly what I want to showcase now. Lombok. Lombok is an interesting project because it hooks into the annotation processing tool facility added in Java 6. What it does is that while the compiler is running, it will encounter an annotation. And given that annotation, there is now an entry point to tell the compiler to do additional stuff. So what is happening in this slide, what you see here, we have a class, the repository object, which is the object that is going to model the information that is coming back from the query that we are going to issue to the GitHub repositories. So remember, this was probably a huge amount of JSON properties in a JSON payload, where the repository object, the bean, is going to model what a repository contains. So we have 4 properties, actually: name, description, file name, and HTML URL. Notice that we're using the Java naming convention, which is camel case. But if we go back to the JSON payload, you will notice that the properties, almost there, use a snake case convention. So we need to convert those names, right? And we need to do that mapping, or that adapt that JSON into Java. So for that matter, we're going to use Jackson, which is the annotations that we see there, for example, the JSON property and the JSON ignore properties. What we're doing with that JSON ignore properties is the following thing. I know that I only have 4 properties mapped, and those are the only 4 that I care. If there are more properties incoming in the payload, I'm going to ignore them. If you don't have that annotation, when Jackson tries to do its thing and he finds a property that is not matched in the Java bean, you're going to get a runtime exception. So this allows you to handle many different kinds of payloads without having to define all the properties. Also, the add data annotation. This one will generate getters and setters for each property, an equals and a hash code, and 2-string method for your bean, and a constructor. And this is not the immutable version. This will be getters and setters. And the final thing, I know it looks a little bit weird, we have an add setter annotation with another argument that says ampersand, underscore, underscore, and then the JSON thingy. Looks weird, but what we're doing is instructing Lombok to append that additional annotation, in this case JSON property, to the generated setter. Every time we rename the property, then all methods, getter and setters, will be generated by the compiler. This means that you have to have some kind of look-ahead facility in your IDE to get code completion. Well, Lombok is supported by all major IDEs. So you should be good to go no matter which IDE you choose to use. Here's another example. Have you ever used the builder pattern? Perhaps using Fluent interface design when you invoke a method, set the value, and then return the same instance so that you continue chaining methods? Well, that's exactly what the add builder annotation allows you to do. Following the conventions of the getters and setters, then passed on all the arguments you're saying, you will have in this particular class a with name if you give it a prefix to the name of the method, or in this case just name parentheses and full name parentheses, description parentheses and HTML parentheses. These are the methods that you're going to use to create a new instance. And the last thing you do is .build, and boom, now you get an instance. So in this way, you can define immutable objects for which the constructor is private, but you still can have the builder pattern in order to create a full-fledged instance with all the values that are required. If you happen to use the JSR 305 annotations, not null or nullable, in the arguments of this method, which can have any name you want, then Lombok will also validate, if it's not null and you pass a null, it will validate that and will throw out a null pointer exception saying, this property was expected to be non-null. Please give it a value. That's pretty good. Here's another example. Lombok can be used to create POJOs that have a different hierarchy. So in this case, I have a subclass of an application event, and it's a full-fledged POJO. Just add data, and I can also override the generation of the equals hash code to a string and all the other things that add data would do for me. It's as simple as that. I really like to use Lombok a lot. We have put into work, even if with our customers, most of our customers are banks or financial institutions. Some people don't trust Lombok too much, but if a bank which is quite conservative in many respects, uses Lombok for their production code, I guess that most of us will be fine using Lombok as well. You have to be aware that it relies on the APT processing tool. So if you don't have annotation processing enabled in your IDE, then Lombok will not work. So it's just a tick mark in NetBeans and IntelliJ. And in Eclipse, there is one additional step that you have to do, but I believe there is a new UI that allows, a new UI in the Lombok project itself, allows you to configure Eclipse very, very easily. Many of the usages of what you expect in creating well-behaved POJOs and a few other things have already been created as Lombok transformations. Creating your own Lombok transformation is not for the faint of heart. You have to know how the Java-C compiler works, and you have to know how the Eclipse compiler works. But don't worry, most of the transformations have been written for you already. You just need to consume it, and you're done. Now let's turn into behavior. How are we doing? So far, so good? Remember, you can please ask me any questions at any time you want to. Yes, a question over there. So okay, so the question is, why would I prefer to use Lombok to bind the JSON properties in the model that I have defined to do the mapping in JSON, right? The reason why, let's go back to that one. Why I like to do it in this way is that I know for a fact that this is a mutable object. It has to have getters and setters. And I also would like to put this thing inside a collection. So I need to have an equals and hash code implementation so that I can find the same object if it has different objects, if it has the same values. If I were to write the getter and setter manually, which you can, even if you put add data, that kind of defeats a little bit of the purpose. And I said, it looks a little bit ugly to put that annotation over there with the JSON property and the getter, but this will generate the right amount of bytecode for you already. So it's a little bit of a trade-off. The source code doesn't look like you usually expect it to, but the behavior that you get is exactly what you would have if you were to generate this using a template method from your IDE or just doing things by hand, which will just bloat your source code. So the comment is, perhaps there is an add-on to reduce the risk of a runtime exception. Maybe there is. To be honest, I haven't looked too much into it. And by the way, Lombok is not the only one that can do this. There are two other projects out there that rely on APT. One of them is called AutoValue from Google. Allows you to create immutable objects using also annotations like this one. But it does not hook into other libraries, for example, Lombok and Jackson. So it only works for immutable values, and that's it. Does that answer your question? Okay, perfect, good. So let's continue. Behavior. While your application is running, perhaps you want to know what's going on. You might use JMX if you want to, but most of us are happy to go with some kind of logging. Now, let's get this out of the way immediately. There is no perfect way to do logging. All the logging frameworks that are out there suffer in one way or another. But of all of them, SLF4j is the one that gives you the better alternatives. You have two things, actually, that win over the others. First, if you're consuming dependencies that rely on commons logging, or Java util logging, or log4j, you will have to have all those dependencies in your path, in your class path, right? But SLF4j allows you to funnel all the calls for all these different APIs into one place, the SLF4j API. And once it's there, you can define which actual binding implementation are you going to use. You want to use the simple SLF4j or put everything to log4j or logback or something else that knows how to deal with SLF4j API implicitly. The second one is that the logging methods allow you to use variable arguments. It is a well-known fact that when you use a logging framework, a logging statement, you have to check if the particular logging label that you want to use is enabled. Because if it's not, you're paying the price to construct the message, send it to the logging backend, only for the logging backend to say, is the log level info enabled? No, it's not. OK, so I'm just going to discard it. but you just pay the price to create that message. So what you have to do is sprinkle your code with if log level info enable, then log info, right? But if you use variable arguments, you can say log info, template in a string, and then all the values. And internally, the method will say, is the level that we have been requested enabled? No. OK, so I just discard everything else. You didn't pay the price to construct the whole string, the whole message. So that's pretty good. If you're not using SLF4j, you might want to use log4j2, which is a much recent version of log4j, which also has these features. The reason why I propose to use SLF4j is that it is more mature, it has more time out in the market, if you will. So there are many other projects out there that already use LSL4j as a dependency, not so much for log4j2. That may change in the future, so be aware of the two. Both of them give you pretty much the same capabilities. OK, now we get started, really started with HTTP. So how many ways out there in Java to create an HTTP client? How many ways out there to just issue a query to HTTP? Is there a standard HTTP client in the JDK? Does anyone know? There is one. You can use just standard URL connection, right? But then you have to handle the HTTP error codes, and once you get a response, you have to parse that response into that particular format and then do more stuff, right? So it's very low level. Say that you go with that route. How many ways out there to construct a REST client? Because one thing is to say HTTP, which is very low level, but another one is to say REST, because now you have to comply with the semantics of a GET call, or POST, or DELETE, or PUT, right? And no matter how we do this, we are always going to follow those constraints. So if we choose this library A to do HTTP, we're going to have to create this abstraction for REST. Or we go with library B for HTTP, we're going to construct the same abstraction for dealing with REST. So wouldn't it be better if we have this abstraction already? Well, there is. First, let's look at OK HTTP. This is a project created by the guys from Square. This project runs in Java and Android. They target the Android platform, which means the library is quite small in memory footprint, and it does a lot of things. Because, well, if it runs on a small embedded device or a phone, then it should be good to go for a desktop or even for a server, OK? So what we do here is basically we create an instance of the client, then create a request with several parameters if you want. You can also configure the headers. You can configure HTTP interceptors to add authentication if you want. And then just issue a call. In this case, we're issuing a simple, a post with some body in a JSON format. And we get a response object. On the response, you can query the headers, if the response code was successful. And if that's the case, then you can grab the body of the response, which is likely going to be in some format, and then transform that format into exactly what you need. It is a basic HTTP client, but it's also a basic HTTP2 client, which should be very important in this time and age also. HTTP2 is the future. OK HTTP is one of the first projects that supports HTTP2 already. Configuration is extensible via factories, and we're going to see that in just a moment, how we can translate the JSON using OK HTTP. And the life cycle of all the HTTP calls are also reachable to you via a set of interceptors that you can define. OK, so how do we add Java on top of this HTTP? Now we can call an HTTP URL. We can call an REST URL. Perfect. But we get JSON. How do we get map that JSON object into a Java object? I guess first we have to know, is the response OK? Is the status measure the right one? Is the content the right one? Is it the right format? Is it the right amount of data? Did we receive everything? Is this thing being streamed? If it's chunk and whatnot? So many low-level things that we have to take care of. And wouldn't it be better if we had something that did this already? Well, there is. It's called Retrofit. Retrofit gives you the following. You, as a Java developer, define just an interface with the contract of the things that you expect. For example, given a method name, repositories, can be anything. With a parameter, with that annotation, a name, this is the name of the organization that we expect, we get as a result a list of repository objects. Good. The next thing is that if you didn't know, the GitHub API is paginated, so we can get many results. And in the headers, we get a links object, or actually a links header, that can tell me if there's a new page or what is the previous page. Given that URL, I can follow that page and continue going on, right? So we have to issue a second call in order to traverse the next page and the next page and the next page until we are at the end. So that's the second method that we see there. It takes just one argument, and that is the full URL, because that's what the GitHub API will give me as a result. And if I issue that call, what do I get as a result? Another list of repository objects. That's what I expect as a Java developer. All right. That cal object that you see there is a type from Retrofit that can give me access to the status code, to the response object, to the headers directly, in case that I want to do some low-level processing. So the next thing you do, once you have defined an API like this one, just one interface, is configure the Retrofit Client itself. We're going to use the builder pattern. They didn't use Lombok. They built it on their own by hand. So you define the API. What is the URL? In this case, it's the API github.com directly. But you will see in the code, in the repository, this thing has been parameterized using dependency injection. We use the Jackson converter factory so that this thing will know that if it receives JSON, it will use the Jackson library to transform into Java. And then we create the client itself, wrapping around with that interface. So basically what this code is doing is creating a Java lang reflect proxy that wraps around that interface. Inside that proxy, there's some HTTP client. There's so many things, but you as a developer, the only thing that you have to do is the last line. Just call GitHub API, which is a proxy, .repositories, path as a string, and as a result, you get a list of repository beans. And that's it. All the mapping happens automatically. Yes, I like that smile, because that's as easy as that is. So the advantage of Retrofit, is this thing still working? Oh, yeah. It wraps REST calls with Java interfaces. You just define an interface. Boom, you're done. Under the covers, you have an OK HTTP client, which means that if your server is HTTP2 ready, your client is going to be HTTP2 ready as well. It's extensible via factories. We just saw the Jackson one, and in the next step, we're going to see another factory. So far, so good? OK. We're dealing with a Jfix API, so we have to deal with multi-threaded code. There is one rule that you have to know if you're building desktop applications. Anybody here that used to build Swing apps? Yeah, a few hands. Whoa, plenty of hands. Jfix? Where are my people? A few hands. OK. There is one rule that you have to take care of, and this might be true if you're building also servers. Anything that is inside the UI thread, that means the painting and drawing, has to be done inside the UI thread. Anything that is not UI related, for example, querying a database, accessing the network, accessing the file system, has to be done outside the UI thread. So you have to think in terms of multi-threading anyway. So we have to do the same thing here. Being a JavaFX application, it wouldn't make a lot of sense to click the button and issue the network call inside the UI thread, which means that the application looks like frozen in time, until the network call finishes, all the post-processing, boom, you get the results. This is why Swing application sucks, because many people do network calls inside the UI thread. Anyway, so can we do things better? Yes. And the JavaScript community has created or has taken inspiration in some other things. And you might have heard this concept before. It's called promises. So if you create a promise based on a task, the task is going to run on a background thread. And once this thing is done, you get called back. Hey, here's the result. If this thing fails or rejects the value, you also get called, hey, this is the reaction. If this thing is canceled, you can also react like, oh, the task was canceled, so what can you do? Is there such thing as promises for Java? Yes, there is. There's this project called JDFR. JDefer gives you exactly the same idea of promises from jQuery, but in Java code. Basically, what you do now is this. You define a service method when you return an object of type promise. And the promise is parameterized by 3 types. The first one is the type of object that you expect as a return. In this case, a collection of repository objects. The second type is what you expect to be thrown if the background task fails. It can be anything. I just chose to be throwable, but it can be anything that is not even in the throwable or in the exception hierarchy. And this is very cool. If you remember swing worker, if you have a background thread processing and you want to publish intermediate results to something, then that is the third type. If, while this background task is handling the repositories calls on the network and going through the different pages, if I want to tell to the UI, hey, here's a new repository and here's a new one, then the type will be repository. In this case, I don't care. I'm just going to consume everything, and then once it's done, I'm going to give it back to the UI. So the third type in this case is void. I'm not going to do any progress at all, or publish any intermediate progress, as a matter of fact. So once we do this, fine, this is how we're going to consume it. We need to know how we set up the publisher. Here is the publisher itself. It's one component using annotations, using injection. There's this type called Defer Manager from JDefer. It's pretty much a wrapper around a thread pool that knows how to issue background tasks. And when this thing is done, or canceled, or failed, it will do the right thing on the promise. It will call the right callbacks. So this is what and I also like to use lambdas a lot now. So what we're seeing here is Defer Manager when, okay, we're setting up a task. This is the background task. When we issue a call like API repositories, remember this is a network call. This should happen outside of the UI thread. And when this thing is finished, what we get? We get a response with a list of objects. Nice. If the response is successful, we don't even have to take care. What is the status code? Is it 200? Is 201? Is it 301? We don't care. If it's successful, then we got the list of objects. So we just simply respond with that. And if it's not successful, then we throw an exception. We'll see how the promise will deal with this one, right? So all this computation will happen in a background thread. How do we consume this? Well, say, for example, you have a controller object, and you have some parameters coming in a model object. So I like to use MVC when defining UIs. And this is the body of the controller itself. We read the parameters from the UI. Perfect. And now we issue the call. That is, we get the promise. GitHub.repositories, some value. And as a result, we get a promise with all the types. Perfect. At this point in time, the background task is started. It's running out there, trying to get all the repositories, calling the GitHub API. Perfect. And your promise here in your controller, what you're saying is, if you happen to give me any progress, then I'm going to grab that repository object and add it to a list. If you happen to fail, then I'm going to print out the stack trace. And when you finish, regardless of if I was a failure or if I was a success, that is the always, I want you to change certain property, model state. Let's see if I can run the application once more. The password is Jfokus 2017 for the network. No, thank you. Not yet. Come on. I'm not done yet. We were going somewhere in here. And did I get the application running? Let's run it again. One more time. And if it doesn't work, well, I still have one way to show you that it actually works. Let's see it once again. I don't have network. It's not going to work. OK, so go back to this. Thank you. I will show you how it can actually work. OK, so we went through retrofit. Perfect. And JDefer. All right, also.
One question there.
Yes.
How is it better than the corresponding features in Java 8?
So the question, how is better JDefer than the corresponding features in Java 8, specifically naming completable future? completable future is too fat. It has too many things. It does too many things. Whereas JDFair goes to just do promises. Now, you can use completable future as well. But then, when you use completable future on its own, it will be running in its own thread pool, or the common thread pool, unless you explicitly say, I want to run this completable feature in such pool and whatnot, right? So in this case, here you have a little bit more of the coupling within the abstractions. And we are actually looking, the author, Ray Sang, is actually in another room right now, giving a talk. He's the author of the library. Yesterday, we were working at the Hackathon. So to make a release of this thing to go in the next stage, which is promises in EA6, the JavaScript 6, work in a very different way than in jQuery. So we're going to give you the two models, the old model, jQuery, and the new model, ES6. So once you have those things, you will be able to have a much better information on which approach you would like to work best. Did that answer your question? Yes. Perfect, thank you. All right, so we deliver the concept of promises. Wow, time flies. Promises can be chained. It's Java 8 friendly, and it's only one-shot execution. You do a background task, and then boom, you get results, or you get nothing. That's it. What happens if we want to have a continuous set of results? What happens if we want to have a stream of results? Can we use Java 8 for this? Not yet. But we can turn into reactive programming. And in reactive programming, we have many things. But perhaps the project that most people know or are aware of is called RxJava. Here's RxJava. Basically, you have an object of type observable, that is RxJava 1. Or if it's RxJava 2, you have something called flowable that supports back pressure. That means the producer is producing a lot of data, but the client is very slow. You want to just push down the producer a little bit, like, wait, I will finish this thing, and then I can continue processing. That's what flowable does, or observable doesn't. So basically, what we're doing here is observable, similar to promises in a sense that I will issue a call somewhere in the background thread, and if this thing finishes correctly, that will be on terminate. We're going to change our state. But when we start this subscription, when we start to consume all the data, we also want to change some other state. That changes how the button reacts. And we also want to subscribe on a different scheduler so that we can make sure that the task is running in a background thread. If we do not do this, then the task is going to run on the same thread as the caller. That would be bad, because in this case, it will be the UI thread. Once we subscribe, every incoming object, every event is going to be handled by this method reference right there, model get repositories add. We expect a repository object immediately gets added to a list. And if we get a failure of some sort, then we're just going to print out that thing. That's as simple as that. How do we set it up? This is consuming. How do we produce? Retrofit can be used with RxJava. So the only thing that we need to do to change our interface, instead of using call list repository as the return value, what we do is observable response with the list or collection of repositories that we expect to be mapped. That's the only thing. We got an observable. Well, we also got a list. We got multiple results per page. Is there a way that we can, I don't know, compose or even flatten several lists into one list? The guys from Scala know this. You call flat map. In Java 8, you also have flat map. Well, guess what? Observable also supports flat map, and that's what we're going to do. Setting up the Retrofit Client to be aware of RxJava is just a matter of adding one line of code. Register the RxJava factory, and you're done. Same thing as before. Now, paginating. This is what I mentioned about the flat map thingy. You have to deal with the first method, which is giving an organization name. You do one thing, and if you have a page, you're going to follow an URL, which is the other method. So this abstraction right here, which is found in the repository, tells you, oh, is the first call or the second call? Perfect. Once you do, you're going to call into that thing called a paginated observable, which is this method. And this is where we do the flat mapping. And this is where we find out if the links header right there has the next page. And if we do, we follow that, we get a list of repositories, we flat map, at the end we just get a single stream of repositories objects inside a single observable. We don't have to deal with list of, we just have to deal with the bin object itself. Our Java gives you observable pattern. It's nothing new. The observable pattern is pretty much what we do in UI. It's events. Surprise, surprise, you're doing UI programming on the server side. Java desktop is still important. And you can deliver, it delivers a lot of operations. You can do flat map, box, zip, excuse me, and many others. Finally, component communication. Wow, I spent too much time in all this stuff. Sometimes you want to have components to be communicating with one another, but you don't want one component to have a direct reference to the other so that I can call directly into that. So try to not use dependency injection in this case. How can we tell component A to send a message to component B in this case? What would you suggest? What can we do? How does this sound look like? Does it sound to something similar? Well, what about sending events? And for that, we need an event bus. If you're using Java, there is an event bus already. It's quite simple. Ambassador gives you more bang for your buck. Basically, what you do is the following. You grab an instance of an event bus. An application event bus is a subclass of an event ambassador type. It's one type that you guys control. And this thing allows you to publish events. Perfect. So that's exactly what we're doing here. If we get an error, what we do is we publish an event in event bus. And by the way, we publish it async, which means we don't care about who is handling the error. Here's the error. Just deal with it, and I continue to do some stuff. Perfect. Publishing. How do we consume? Here it is. As any class, you define a method with @handle. @handler, as a matter of fact. The important thing is not the name of the method. It's the fact that it's annotated and the type of argument it receives. That will be the type of event you're interested on. Notice that we also use post construct and pre-destroy to register this instance with the event bus itself. So now that this is set up, when someone publishes a throwable event, this event listener or this event handler is going to be invoked. And that's it. As easy as that. Now, I like Ambassador a lot, but there's a caveat. It is not that much maintained anymore. The author is moving out to other projects, though the current state of the project is pretty good. We use it in production. So you can use it with confidence, but be aware that if you ever find a bug, the response time from the team is not going to be as fast as you might expect. All right? I only have a few more minutes for testing. I can't believe I spent so much time on the other stuff. Excuse me. But I can go quickly to this. JUnit 4. Who uses JUnit 4 here? Plenty of people. Anybody still testing JUnit 5? No? All right. So you know that in JUnit 4 you can parameterize test case. But you can only parameterize a single test method because it must take the same number of arguments with the same types. If you use JUnit params, you can have as many test methods with any type of arguments, with any cardinality, and anything. So just, boom, it explodes in a sense that now you have much more freedom. Anybody using mocking? If not, then I suggest you to use Mockito. It's the best one. Seriously, there is no other mocking framework that can compete with Mockito. And it's updated almost weekly, if I'm not mistaken, or at least twice a week. Now, what we're doing here in this particular method is right there in that controller get service. The get service is a mock. We're declaring an expectation. I really like it because you're using the real API of the object that you want to mock, or a stub, or a spy, which is a real object that will give you real responses, but some of those responses might be a stub responses or mocks. The other one that I like is Jfokus. If you're using JUnit and Google Juice and Mockito, well, Jfokus is the three things combined. It allows you to use @inject in your test case automatically, coming from the Juice container. And here's the kicker. If you do not define a mapping for a type, that type is going to be automatically mocked by Mockito. So in this case, the sample service that you see there in the before method is a real Mockito mock coming from the Google Juice container. That's pretty cool. Spock, if you are willing to expand your horizons into other languages, such as Groovy, as I said earlier, I'm a Groovy fan. Spock gives you many things that you find in JUnit params and Mockito as well. Spock has its own way to do mocking inspired by Mockito. The two authors actually used to work together in the same company. And you have parameterized test cases. You can change the method name. Does that method name look weird to you? It's a string, isn't it? Ah, but you can do these things in Groovy. Crazy, I know, but useful. And finally, and I'm going to run this now. Our utility is for handling concurrency. If you're running, as we said, our controller invokes an action outside of the UI thread, does some work, and eventually comes back inside the UI thread. How do we test this? How do we do an end-to-end testing when we had to deal with multiple threads? We usually do thread.sleep, right? Or something like that. Our utility gives us a DSL to deal with concurrency. So in this case, in this method, controller.load, we expect a background thread to do the work and eventually come back. What we're saying there is we're going to await certain timeout until a condition is fulfilled. If that condition is fulfilled, the test continues. If it's not, we have failed the test. You can use handcrest matchers. You can use many things here. I think I'm using a method reference, which actually that is a callback, a callable, and the other one is a handcrest matcher. And finally, if I want to test a REST API, it's fine if I have the client, but how do I test the server? Do I have a server always running? Do I hit the actual GitHub API? No. What if I can bootstrap a server at the same time as I'm running the tests? That will be the usage for wiremock. What we're doing here is bootstrapping an HTTP server, a fake one, on which I can say, given these sets of requests with these certain parameters, I want you to respond with this thing. And you can also have delays of response. You can do whatever you want with the headers. So if I run the test now with wiremock enabled, it doesn't matter that I don't have any network. I can say GW, and let's run clean and test. Notice that my hands will be out of the keyboard, and the UI will appear in just a moment. This is another testing framework called TestFX, just for JavaFX. But behind this, there is wiremock server, making sure that all those calls, those repositories are coming from a real HTTP server. That is wiremock under the covers. All right? Perfect. I think we're pretty much done. This thing is kind of working. OK, so remember, all these libraries are open source. If you help open source in a way, thank you very much. If you do not, don't worry. There's still time. You can contribute just by sending a report whenever you find something that is not working right. But if you can supply a test case, or you can even supply code to fix the bug or add the new feature, much the better. Thank you very much for your time.